The last three examples that we're going to do involve solving radical inequalities. This is a little bit different from solving radical equations, and the procedure is outlined on the top of the page for you. Number 1, the square root of 3x minus 6 plus 4 is less than or equal to 7. Well, according to the procedure, the first thing we're going to do is solve for x or isolate x. So I'm going to say the square root of 3x minus 6 is less than or equal to 3. I'm then going to square both sides, and I'm left with 3x minus 6 is less than or equal to 9. I'm going to add 6 to both sides. 3x is less than or equal to 15. And then I'm going to divide by 3. X is less than or equal to 5. But I'm not done yet. If I look at the procedure, I'm also supposed to find the domain of any expression under a radical. Well, there is an expression under a radical here, and it's 3x minus 6. And in our study of domain earlier in the year, we said that things that live underneath the radical must be greater than or equal to 0, or else they'll end up being imaginary. So I'm going to say that 3x minus 6 is greater than or equal to 0, which means that 3x is greater than or equal to 6, which means that x is greater than or equal to 2. So we have these two conditions that are sort of coexisting at the same time. So I'm going to make a number line, and I'm going to put 2 here, and I'm going to put 5 here. And the second condition was that x had to be greater than or equal to 2. And the first condition was that x had to be less than or equal to 5. So the one place where both these conditions are met seems to be between 2 and 5. So the answer to this problem are all those x values that are between and including 2 and 5. Okay, number 9. I'm going to solve for x, and I'm going to do this by taking the problem and squaring both sides. The left-hand side squared is x minus 3. The right-hand side squared is 5 minus x. Shifting things around, I have 2x is greater than 8. X is greater than 4. But we're not done yet. There's an expression of the original problem that lives under a radical, and that is that x minus 3. And x minus 3 has to be greater than or equal to 0, which means that x is greater than or equal to 3. There's another condition, and that is 5 minus x also lives under a radical, so it too has to be greater than or equal to 0. Negative x is greater than or equal to negative 5, and we have to flip the switch here. X is less than or equal to 5. So when we make our number line, there's actually going to be 3 elements of shading. Our critical numbers are 3, 4, and 5. Using the green pen, x has to be greater than 4. Using the blue pen, x has to be greater than or equal to 3. And using the orange pen, x has to be less than or equal to 5. And there is a place where all 3 of these colors overlap, and that starts here, and it goes all the way to here. So the final answer is going to be starting at 4 and ending at 5. The 5 is included because there's a solid closed circle there, but the 4 is open because it's an open circle. For our last example, we're going to solve another radical inequality. I'm going to start by isolating one of the radicals. The square root of x plus 5 is greater than 2.5 minus root x plus 10. Now I'm going to square both sides. The left, I'm left with x plus 5. And on the right, I'm going to write this out twice. And I'm also going to switch from decimals to fractions. I just like fractions better. I'm going to leave the left side alone, and on the right side I'm going to FOIL. First is 25/4. Outer and inner together leave me with minus 5 root x plus 10. And last is plus x plus 10. Cleaning up a little bit on the right, we've got the 25/4 in the front and 10 in the back. If you think of 10 as 40/4, we get 65/4 in total. Now I'm going to subtract x from both sides. There's an x on the left and on the right, so those are just going to drop out. Now I'm left with 5, or 20/4, is greater than 65/4 minus 5 root x plus 10. I'm going to take this negative radical and move it to the left-hand side, making it positive. 5 root x plus 10 is greater than 45/4. Now I'm going to multiply both sides by the reciprocal of 5, or 1/5, to get rid of that 5. Now we're left with root x plus 10 on the left-hand side, and we're left with 9/4 on the right-hand side. And once again, I'm going to square both sides to keep the process going. The left becomes x plus 10, and the right becomes 81/16. Okay, I'm going to come up here where there's a little more room. Now x, and actually this is not an equal sign, this is a greater than sign. X is greater than 81/16 minus 10. But instead of subtracting 10, I'm going to call it 160/16. X is greater than negative 79/16, which is equal to, let's see, negative 4.9375. Now, we're not done yet. We have to consider the domain of any expression that lives under a radical. So up here, we have x plus 5 must be greater than or equal to 0. X must be greater than or equal to negative 5. Over here, we have x plus 10 is greater than or equal to 0. So x is greater than or equal to 10. Now we're going to take all three of these responses and put them on the same number line. So actually I made a mistake. This is negative 10 right here. So on our number line, we're going to put negative 10, we're going to put negative 5, and we're going to put negative 79/16. Now, in green, we're going to say that x has to be greater than negative 79/16. In this brown color, we're going to say x has to be greater than or equal to negative 10. And in this blue color, we're going to say that x has to be greater than or equal to negative 5. Now, the overlap begins at this negative 79/16, and it goes all the way to positive infinity. So the final answer using interval notation is going to be negative 79/16 to infinity.